Hello dear student. Today lecture unit and dimension, lecture number 2, class 11, chapter 2. So now topic now continue here. Topic is dimension analysis. Dimension analysis. Dimension analysis. Topic is dimension analysis. Already complete many physical quantity. Find out the dimension. The next, I think number next year, next physical dimension quantity next year. The numbering is, I think 10 number physical quantity, 10 to 11. Next year physical quantity, find out the physical quantity. Unit and measurement, lecture number 2, for class 11, chapter 2. Now the next physical quantity here. Next physical quantity, refractive index. Next physical quantity, refractive index. Refractive index. Next physical quantity, refractive index. Next physical quantity, refractive index. Now refractive index, refractive index equal to speed in medium, 1 by speed in medium 2. Then here, so speed, so upper quantity speed and so here speed, here speed, here speed, so cancel. Then dimensionless quantity, so m0, l0, t0. Refractive index is dimensionless physical quantity. Refractive index, dimensionless physical quantity. Then next physical quantity here, potential difference. Potential difference. Next physical quantity, potential difference. Potential difference. Next physical quantity, potential difference. So potential difference is work done per unit charge. Work done per infinite distance, q charge in a electric field. Then work done is W. So unit charge for the work done is Q upon W upon Q. So potential difference W upon Q. Potential difference W upon charge per work done per unit charge. Work done per unit charge. Potential difference. So potential difference here. Potential difference work per unit charge. Then here work here W equal to F into S. W equal to F into S. W equal to F into S upon Q. So dimension. So put now dimension. F dimension now put here. Now dimension put here. MLT minus 2. MLT minus 2. Next dimension here. S dimension is L. S dimension is L. Or here charge, electric charge here. For a conductor T second charge follow Q is unit time charge follow Q upon T. For a conductor, here a conductor, suppose a conductor is T time is charge follow is Q, T time is charge follow is Q. So unit time charge follow Q upon T. From the definition of electric current, unit charge follow unit charge in 1 second. T time charge follow Q charge, unit time charge follow Q upon T. So unit 1 second or unit second charge follow of a conductor. This is electric current. The electric current is I upon Q upon T. So Q is I into T. So here Q dimension is I dimension is A, T dimension is T. So now put here Q dimension here A T. Q dimension is A T. So totally here now. Totally here answer. Now this here M L square here L into L square T minus 2 T minus 1 T minus 3 A minus 1. This is the This is the dimension of the potential difference. This is the dimension of the potential difference. M L square T minus 3 A minus 1. This is the dimension of the potential difference. Next physical quantity here, find out now. Now completely now screenshot here. 1 second time here. Now remove this. Next physical quantity now find out here. Next physical quantity find out. Next physical quantity here find out. Next physical quantity here. Number is 12. Number is 12. Boltzmann constant here. Next physical quantity is Boltzmann constant. Boltzmann constant is defined by K. We know that from the Boyle, Charles and Boyle combination law, we have write PV equal to KT. PV equal to KT. We know that PV equal to KT. We know that PV equal to KT. Now here KT equal to PV. KT equal to PV. Now K equal to PV upon T. Now here put now here K. So pressure, P is the pressure, V is the volume, T is the temperature, K is the Boltzmann constant. Here K is Boltzmann constant, P is pressure, V is volume, and T is temperature. Now we have force. Pressure is force per unit area. Pressure is force per unit area. So P equal to force per unit area F by A. P equal to F by A. So pressure equal to force per unit area. Volume is length into area into height. Volume is area into height. Volume is area into height. Area into height or length. T is temperature. T is temperature. Here P is pressure, V is volume, T is temperature, K is Boltzmann constant. So temperature here T. So temperature dimension theta. Temperature dimension theta. So here here temperature dimension theta. Now here A cancel, here A cancel, so here F into L by theta, so F dimension is MLT minus 2, L dimension is L here upon theta, so here M L square T minus 2 theta minus 1. This is the dimension of, this is the M L square T minus 2 theta minus 1. This is the dimension of Boltzmann constant here. This is the dimension of Boltzmann constant. This is the dimension of Boltzmann constant. Here combining Boyle and Charles law, combining Boyle's and Charles law, then we get combining Boyle and Charles law, then we get PV equal to KT. Now here next is here KT equal to PV, so K equal to PV upon T. So now P equal to F by A is area or volume into area into length, T is temperature is dimension theta, so here A cancel now F into L upon theta, so F dimension is ML T minus 2, L dimension is L theta, so M L into L square T minus 2 theta minus 1. This is the dimension of Boltzmann constant. Next here complete now here. Next here then Planck constant here 13 number here. Next physical quantity 13 number Planck constant. Next physical quantity is Planck constant. Energy of photon. Energy of a photon. Here we have energy. We have energy of photon. We have energy of photon. Each photon energy of photon or each photon is equal to h nu. Here E is the energy. Here E is the energy. Planck constant denoted by Planck constant here. Planck constant denoted by h. Planck constant here. Planck constant denoted by h. Here E is the energy, h is the Planck constant, and nu is the frequency. Nu is frequency. Now here, so E is the energy. Here E is energy. Here E is energy. H is Planck constant. H is Planck constant. H is Planck constant. Nu is the frequency. Nu is the frequency. Nu is frequency. Nu is the frequency. Here H is energy. Here E is denoted by energy. H is denoted by Planck constant. H denoted by Planck constant. H denoted by Planck constant. Nu is denoted by frequency. Nu is denoted by frequency. Now this equation, energy of each photon equal to h nu. Then now here h nu equal to E. Here h nu equal to E. Now h equal to E upon nu. So h equal to E upon nu. Now here dimension. So next here energy, work and heat, dimension, heat dimension, ml square t minus 2, 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 or here nu equal to 1 upon t, nu equal to 1 upon t, frequency nu equal to 1 by t. So now here put here energy dimension ml square t minus 2, frequency is 1 upon t. So m L square t minus 2 t1. So m L square t minus 1, m L square t minus 1. This is the dimension of m L square t minus 1. This is the dimension of Planck constant. This is the dimension of Planck constant. m L square t minus 2. Yeah. So Planck constant dimension here. Planck constant dimension m L square t minus 1. This is the dimension of Planck constant. 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 So not everyone note this point. H is Planck constant. So Planck constant dimension is m L square t minus 2, m L square t minus 2, m L square t minus 2. Work is F into S. So F is m L t minus 2, S is upon L. So m L square t minus 2. This is the dimension of E. This is the dimension of Q. Here next here now next physical quantity, I think number 14. gravitational constant. Next physical quantity is gravitational. Next physical quantity next physical quantity next physical quantity next physical quantity is gravitational constant. Next physical quantity is gravitational next physical quantity is gravitational constant. We know that universal gravitational law F equal to G m1 m2 upon r square. We know that F equal to Coulomb's law here. F equal to K Q1 Q2 upon r square. Similar formula for gravitation. Universal gravitational law F equal to G m1 m2 upon r square. F equal to G m1 m2 upon r square. F equal to G m1 m2 upon की r square. F equal to G m1 m2 upon की F is G m1 m2 upon r square. See now here G m1 m2 upon r square, G m1 m2 upon r square equal to F. So G F into r square upon m1 into m2. Now here put the dimension here. Now F dimension is ML T minus 2, ML2 minus 2. Here r square. So r square dimension is L square. R square dimension is L square. M1 mass dimension is M. So mass dimension is M. Mass dimension is M. So here M is cancel here. Cancel. So now M minus 1 L cube T minus 2 here M cancel M minus 1 L into L square, so L cube so L cube T minus 2. So this is the dimension of gravitational constant. That means G. This is the dimension of gravitational constant. This is the dimension of the gravitational constant. This is the dimension of gravitational constant. Then next physical quantity is now find out. The next physical quantity is now complete. Now it is here 13, 14 number. Next physical quantity is angular suppose a particle suppose a particle move in a straight line. Suppose a particle move in a straight line, then the velocity is a linear velocity. Then the velocity is a linear velocity. But a particle is moved on a circular path. A particle move on a circle. Then angular velocity. Then we get angular velocity. Then we get linear velocity. Suppose a particle move in a straight line, then we get linear velocity L. But a particle move on a circular path, then we get angular velocity omega. Now here, find out the dimension of angular velocity. We denoted by angular velocity omega. We denoted by angular velocity omega. We denoted by angular velocity omega. So V equal to omega into r. This is the relation between angular velocity. This is the relation between linear velocity and angular velocity. V is linear velocity. But omega is angular velocity. V is linear velocity. But omega is angular velocity. R is the radius. Actually here V into omega cross r, V equal to omega cross r. Here V equal to omega cross r. V omega r sin 90 degree. V and V omega VR V into VR r 90 degree. So sin 90 is 1. So V equal to omega into r. Sin 90 is 1. So now omega r into V. Omega into r into omega r equal to V. So omega equal to V upon r. Omega equal to V upon r. Here V is the velocity. V is the linear velocity. R is the radius. So velocity is displacement upon time. Velocity is displacement upon time. Radius is r here, radius. So r is the dimension is L. So displacement dimension L upon T. Here dimension r is dimension is L. R is dimension L. So here L cancel. So here T minus 1. This is the dimension of omega. Omega is angular velocity. Here omega is angular velocity. Suppose a particle move on a circular path, then we get angular velocity. But a particle move in a straight line, then we get linear velocity. Linear velocity is V. So this is the dimension of omega. So omega equal to t to the power minus 1. So omega equal to t to the power minus 1. This is the dimension of angular velocity. Angular velocity. The next physical quantity now here find it. The next physical quantity find out here now. move now erase here. The next physical quantity 15 number. The next physical quantity angular momentum. Angular momentum. The next physical quantity is angular momentum. So angular momentum is momentum is denoted by L. Angular momentum is denoted by L. So angular momentum L. So angular momentum L here. Angular momentum L equal to m into r cross m into r cross v. L समान m into r cross v. So here v are r, v is the velocity, r is the radius. V here this is the r, this is the velocity. Velocity and radius perpendicular. Velocity and radius perpendicular. That means 90 degrees. So 90 degree. So v r sin 90 degree. So v into r sin 90 degree. Sin 90 degree 1. Sin 90 degree 1. So v into r. So L equal to mvr. So angular momentum denoted by L. So angular momentum denoted by L. So now here L is mvr. So L here m is the dimension. M is dimension. M is dimension m velocity dimension, displacement upon time L by t, L by 2. R is the radius, so radius is dimension is L. Radius is dimension L. So now completely angular momentum dimension L is m L into L square t minus 1. This is the complete dimension analysis angular momentum. Then the next class other remaining physical quantity found out. Share all dear student. Have a good day. Good night.